Here's our mountain bike physics problem on angular velocity and rotational kinetic energy. You just watched Blake Samson do a turbo flip 360. That sets us up perfectly for our physics problem. Here it is. Suppose Blake Samson contemplates doing a turbo flip spinning at 0.800 revolutions per second, fully laid out, body extended. His moment of inertia would be 2.34 kilograms times meter squared. He's read the no dying allowed sign and decides it's a better idea to tuck his bike a bit closer to his center of mass, where his moment of inertia will be 1.49 kilograms times meter squared. This problem has two parts. Part A, what is his angular velocity in revolutions per second after he pulls the bike in closer to his center of mass? And part B, what is his rotational kinetic energy in joules both before and after he does this? Pause the video now, solve the problem, solution will follow. Because there's no net external torque, the angular momentum is conserved. So we can use this equation to solve for our new angular velocity. So our new angular velocity can be found by substituting in following values. 2.34 kilograms times meters squared divided by 1.49 kilograms times meters squared times 0.0800 revolutions per second gives us an angular velocity of 1.26 revolutions per second. In part B of the problem, to get it into the right form, we're going to need to convert to radians per second. So our equation for solving this problem is rotational kinetic energy is equal to 1/2 moment of inertia times angular velocity squared. So in our first part of the problem, before the tuck, 0.5 times 2.34 kilograms times meter squared times 0.800 revolutions per second. We're going to convert to radians per second by using two pi radians per revolution. Square that. Oops, missing the square there, but that is squared. And our answer will end up being 29.6 joules. In the second part of the problem, same equation, kinetic rotational energy, 0.5 times, now our new moment of inertia, 1.49 kilograms times meters squared. Our new angular velocity was 1.26 revolutions per second. Again, we're going to change that to radians per second. And again, there's a mistake in the equation here. That should be squared. Our angular velocity should be squared in both of these problems to get the answers that you see here. And the new answer is 46.7 joules. The additional work done here is done by our rider when he pulls his bike into his body to change his moment of inertia. In order to get the correct kinetic energy, rotational kinetic energy, you would need to square the angular velocity. So I've made that correction here in orange, squaring both to get these two correct answers for rotational kinetic energy.